Okay, obviously, thank you for joining me today. So this webinar is, as you can see by the title there, sort of BIM for manufacturers. I'm actually a BIM consultant with Autodesk. I've been asked to do this webinar to sort of help manufacturers and so on. So, firstly, obviously, say thank you for joining us. Just a quick bit about me. So, as I say, I am from an architectural background. I studied in architecture, worked in architectural industry, and then got involved in sort of BIM. Well, before it was really BIM, to be honest, but kind of Revit and other programs like that. And I've been with Autodesk now for 2 years, and sort of actively involved in kind of BIM and in the UK. So sort of trying to get involved as much as I can with the kind of BIM shift, as it were. Autodesk as a company, I'm sure probably aware what Autodesk do. Obviously an Autodesk reseller, so a platinum reseller. But aside from that, we also do working in lots of different industries. So manufacturing was always a historic one that we tended to work in, but more recently been in the architectural and engineering side of things as well. Historically work a lot with companies like Kawasaki and stuff like that, from the manufacturing sort of side of things. And then in architecture, some of the big sort of architectural names in this country, so sort of Zaha, for example, there. And now we're kind of looking a lot more at the kind of connection between the AEC industry and the manufacturing industry, which is sort of being provoked really by the kind of shift towards this sort of BIM kind of way of working. So I suppose the first question really is obviously why BIM. So I mean, part of this little presentation, I was just going to kind of go through basically where BIM comes from and why we're doing it, which I'm sure probably people have seen before. But and then obviously lead that into really obviously what's available for manufacturing and how things are working for manufacturing. So the government construction strategy stipulated that they wanted to try and reduce the carbon footprint of new builds and buildings by about 20%. To achieve this, they wanted to use building information modelling technologies, as they called it, to work through the process and collaborative working, and try and basically work in a more kind of efficient way, not just in the actual design and construction phases, but also through project life cycle as well. So obviously that was mainly aimed at sort of capital projects, so projects that were involved with the government, and projects of a certain size. But as that's sort of shifted on, people have now sort of latched onto that, and therefore I think the main thing is that has a knock-on effect with everybody. So a large project has contractors, subcontractors, subconsultants, and some of those can be quite small companies getting involved in something that obviously is a very much larger project. So BIM, obviously just an acronym really, and really means different things to different people. The building information modelling bit is sort of where Autodesk sort of geared it from really, but from my point of view, I tend to think of it more as sort of management of information, and obviously it's data management in the sense of, particularly from a manufacturing point of view, I think nesting data into side objects that can then be populated into a building, a virtual building, and then be interrogated and sort of quantified throughout the kind of build process is really the major key here. And obviously, as I say, I mean, it's now moving on to the more lifecycle management side of things as well. So project lifecycle management, which again, if there's sort of nested data inside of components in buildings, and in the sort of building information model that is being created, then obviously that data is going to be taken through into the life cycle of that building as well, and then can be utilised obviously later on down the process of the management of that building. So BIM, obviously what people do tend to refer to it as, I mean, it is digital prototyping. I mean, it is building a building in a digital format to be able to test it, analyse it, check that things aren't going to clash together, check that things work properly, check that spaces are allowing enough space to do the things that need to be done. It also allows things like components and stuff to be tested, and in the manufacturing side of it, historically that was always done through things like sort of car manufacturing stuff. Obviously they tested components to ensure virtually that things were working efficiently and designed in the most efficient manner. So in a building sense, that's basically exactly the same as what we're trying to do now in building information modelling. Really just run those tests through. It can be 2D or 3D. It doesn't necessarily have to be 3D information. AutoCAD that people tend to do can also be BIM. It's more just trying to make something that's very rich in data that can then be utilised later on. But generally it is something that now leads itself into 3D because obviously that sort of virtual building system. It does lead into design visualizations as well. People use it particularly in the architectural industry now as a tool to visualize things. The visualization can then be obviously utilized to communicate design intent and communicate with obviously a client or other contractors, subcontractors. As I say, that whole virtual design and construction process just means that things can be sourced, supplied, specified, and obviously checked inside of a building through the process. So the adoption BIM, obviously, BIM in itself has been around really for quite a long time now, although it might not have been termed BIM. The idea of obviously 3D modelling and trying to create data-rich sort of models that has been around for a long time. And initially, architects started adopting it really. So see here, obviously, the largest percentage in the chart in sort of 2009 was architectural. But now there's a lot more of a shift towards contractors, particularly. It's expected that this year, in 2014, obviously you can see in this slide here that the largest increase over those years from 11 to 14 is the contractor side of things. Really that has a big knock-on effect because obviously the contractor is the one who is organising the project. They're the person who's going to be eventually kind of specifying the bits and pieces that go into that building. So although an architect might specify something through the design process, sometimes for a process of value engineering, the contractor will then lead that and then put in whatever they see fit that might be a cost saving or whatever. So if there's manufactured components out there available that contractors can then utilise, they would then probably be using those to specify because it would just be simpler for them. So I think making manufacturing details available, particularly to contractors, is going to be the key to successful kind of manufacturing implementation within the kind of BIM field. The awareness of BIM is obviously something that's increasing drastically as well now. So something that over these last few years, people initially sort of saw BIM as is it going to happen? Is it going to happen? Is it something that we need to sort of be thinking about? And I think from an AEC point of view, that's was always the case a couple of years back, whereas now it's kind of assumed that this is process, this is what's happening, this is how it's going to work, and people are sort of looking at that in a lot more detail now. I think that also means that because it's now assumed that this is the process that's going to happen, that things like manufacturers and the publicising of components to put into BIM models is something that needs to happen as well. So therefore I think the adoption of BIM in its entirety will obviously have that kind of knock-on effect that components will be required and so on. So obviously BIM is a cultural change. In the AEC field, it's something that people are trying to understand how that cultural change is affecting their process. Obviously historically people had CAD, so did AutoCAD drawings, and it was a very documentation-led field with different disciplines using different CAD formats and potentially different sort of vendors to do that. Whereas now the idea obviously is to have that kind of building information modelling that's being designed and that process leading into documentation. But documentation just being one small part of that. from a manufacturing point of view, I think that really makes the point that it's not necessarily about producing a drawing or producing a sheet that somebody is designing and building a building to. It's more related to the data that is contained within that model that then can be publicized at the end of a project, taken through to kind of lifecycle management, and as it says there, even through the actual design process as well, be obviously simulated, analysed, and ensured that obviously what's being specified is going to be fit for purpose. The BIM levels is something that people have been sort of branding around quite a lot, and most people tend to understand a degree of what they are. Really just trying to show this slide, which has been utilised a lot, this image, which is the Pyramid Richards one. The idea really of this image is to try and express the movement from a level 0 as it's regarded to a level 3 BIM. So the progression basically going from something that would be 2D CAD based to something that would be a kind of fully integrated BIM model. At the moment, the idea of the government strategy is to take us to level 2. So the red line there sort of represents where the government wants us to be at 2016. That would involve things like obviously integrated BIM models. It would involve different processes than what a lot of people are still using now. And it would also mean that the kind of data-rich environment that a BIM model would produce would require a lot less a lot more in the component side of things as well. To get to that kind of level 2, level 3 BIM, in the AEC environment, that really means changing workflows, sharing data, migrating data between different platforms. All of this tends to get referred to now as a sort of integrated project delivery. Originally, there was different fields inside of a typical design and build sort of procurement strategy that most AEC sort of environments tended to utilise. Now, the idea really, rather than having these separate areas, these separate silos as they tend to get referred to, so instead of just having an architect, an engineer, subcontractors, and that each of those being a separate little field, the idea really with the integrated project delivery system is that it's something that's contained, everybody's feeding into it, and from a manufacturer's point of view, I think that means that architects are looking at specifying manufacturing components, being able to just place things that's going to contain all that data in them. Subcontractors will then be wanting to source stuff and have that they can utilise, or even have stuff publicised that they can already just say, well, yes, this is our BIM content and it's there ready to use. And obviously, whether it's architect or contractor led doesn't really matter. The involvement of subcontractors and manufacturers would be an integral part of that. The workflow that's now being sort of adopted by the AEC field does involve a lot of sort of standards and documentation and a lot of sort of different aspects. From a manufacturer's point of view, it's this kind of project-specific details and libraries that need to be created that's the kind of important one, really. As an architect, as an engineer, as a specifier, as a contractor, all of those will need to start having libraries of data that they can then sort of call upon and say, right, okay, I need this particular part, put that into the building, and then be able to utilise it. People won't want to keep creating those. You can create families, you can create stuff in programs like Revit, but as a manufacturer, if you've produced that data, if you've produced that content and it's already there for people to be able to specify, then when they go to specify it, they'll just adopt whatever's easiest. They're not going to start trying to create their own. So if there is project-specific type libraries available for people to download, they will be downloading them and they will be utilising them inside of projects. So just going back to that little slide about the levels for a second, just to emphasise really the fact that obviously to get that level system to work, that the government have also come up with a lot of standards and guides and classifications and various other things. Most of it is using or adopting stuff that's already been around before, but some of it does have a knock-on effect with things like manufacturers, particularly when it comes to things like the classification tables and stuff. Classifications down there, you can see at the moment we're talking about things like uniclass. Historically, the AEC environment used lots of different methods of classification. In architecture, we used MVS and various other codes. Uniclass has obviously always been in the background. There's the sort of omniclass and Americanized systems. The idea really is that instead of having all these sporadic different systems that nobody really knows what classification stuff should be, the idea is that uniclass at the moment is being rewritten alongside MVS to basically try and sort of make that some one unilateral system. If that's the case, from a manufacturing point of view, any content that's created should also be adopting that kind of standard. It should be created using that classification system so that then it can be translated to everybody, everybody understands it, it can be classified, it can be scheduled out, and then obviously quantified inside of building projects very easily. So I think the important factor here, as I say, from a manufacturer's point of view, is the kind of classification side of things. There are also documents out there as well that talk about how things should be created, so how content should be created, how things that exist inside of the manufacturing differing programs can then be utilized, taken across, and being created into content that is being fed into a building information model. This was just a quick slide just expressing the workflow thing. So you know, in an AEC environment, obviously that sharing data is really key, and publicizing data. And I think from a manufacturing point of view, really just understanding that workflow and where you might be involved in that. Obviously that sharing information, it is something that a lot of companies now are sharing information, allowing something to be up there that in the internet or wherever that people can then utilize and download. Is becoming more and more a normal way to work. So say there are documents out there that aid with the creation of content, in particular when it comes to content that's going to be for things like Revit or programs similar to that. There's also protocols for how the AEC environment deals with things as well. So with those sorts of things combined, we can start producing and ensuring that things like libraries, content that's going to be put into libraries, and the classification of those sorts of items can be correct. Also, I've put up there COBie as well, because COBie is something that at the moment is being adopted as well. I'll talk a bit more about COBie as we kind of go through. So obviously the protocols and the standards that's being used, and then obviously ensuring that any British standards is really important as well. Leading on from the kind of levels thing that we were talking about with BIM there just a second ago, government really is trying to aim us toward this kind of life cycle management. So this slide is a bit complicated, but we're just talking about levels here, going from 1 to 7 in the middle there, which is the kind of going from design through construction to handover and operation of a building. And then the blue arrows really just talking about the life cycle of a building, so the management of a building through life cycle. At the bottom there, really talking about through the design and construction phases, having sort of data drops or drop-off points that information is exchanged around. Obviously there you can see that suppliers' information and the exchange of suppliers' information is a key part of this, and the little green sort of circular arrowing there saying really basically that obviously things need to be communicated, specifications might change, new things might be adopted, and all of that data needs to keep being supplied, resupplied, eventually feed into the kind of BIM model, and then obviously get signed off at those kind of decision points throughout a process. I think this is also quite important, really, this slide, just to point out that you know, the kind of 3 aspects of building information modelling as well. People tend to sort of get stuck on the building information modelling, meaning that you've got to use something like Revit, and meaning that that kind of Revit thing also means that everything is going to be geared around 3D. Everything's going to be 3D. Everything's going to be something modelled. the bit in the middle there, really emphasising the point that we are talking about things that might be documented. We are talking about things that's non-graphical sometimes, that's just data-based, as well as that graphical information, that 3D or 2D graphical information. So again, I think from a manufacturing point of view, we are sort of talking about stuff that's not just modelled or drawn, but we're also talking about things that's data-rich, so something that contains all of the information about the specification, the model, the part number, the ID numbers, all of those sorts of things in that content, so that it's there, it can be called up, it can be scheduled, and it can be quantified. So, and then eventually obviously be documented and make up part of the kind of operations, maintenance manuals, and so on. Just the other effect really is the kind of push and pull effect that tends to get referred to as the kind of sort of supply chain, the push and pull. I think the really important thing here is that that obviously from an AEC point of view, there is this push-pull effect, that obviously you've got the kind of employer trying to pull a project in a certain direction. The client obviously wants something out of the building. From a supply chain point of view, obviously certain things can get supplied. So in the supply chain end, that's going to lead to the supply chain, the supply chain as a whole, including things like subcontractors and very small subcontractors sometimes, and also leading to, as I say, things like the model data that might get supplied into that chain of supply, as well as all the details that might get put into it as well. So I think from a manufacturing point of view, it's just the tier end, or the tier 3, tier 2, whatever, that could be data that's then been put inside of little families, and those little families are then being supplied obviously to contractors or architects, and then being utilised to obviously feed into the sort of the BIM models as they get produced. Also, there's the kind of collaborative working side of things as well. The whole point of BIM obviously is to sort of start trying to work collaboratively with people, and again, that kind of collaborative working really sort of works hand in hand with producing, specifying models and sharing that data around. So I think although initially there doesn't seem to be much of a kind of scope for suppliers in that sort of field, I think it's more just a case of obviously the understanding of how that system works, and how people are now starting to adopt this kind of strategy internally and externally, and that where manufactured data is going to fit into that, and that sort of integrated project delivery and internal collaborative working, how people are starting to try and pool all of these bits of Revit details, little Revit projects, little Revit families, whatever they're going to be, into projects and into building information models to try and start getting that information in there to use at some later point, or take it through into the kind of lifecycle management. So I think it's really just a kind of loop in that sort of sense. So everybody's now starting to all be connected really, and I think that's the key really. So obviously it's fine supplying details, and from a manufacturer's point of view, I think obviously there is a huge scope to publicise whatever's being produced in a manufacturing sense. But as I say, it is key to make sure that anything that is being publicised is being produced in the right way. So the modelled data, the data that's being put in there, the stuff that's being documented, the way that things are being named, and the sort of procedures and the conventions that's being utilised, all of those sorts of things are really, really important going forward to ensure that everybody understands what's being produced and what they're then going to be eventually putting into these building information models. In an AEC field, we use what we call level of detail, or LOD. So I think from a manufacturing point of view, this the sort of chairs image there is quite a nice one really. That obviously if I'm a specifier or I'm an architect, and I'm putting into my BIM project, initially I wouldn't really be worried about what my chair looks like. I wouldn't be worrying about whose chair it is, where it comes from, what manufacturer, what details it's got inside of it. I'm just going to be looking at, that's a chair, that's it, that's all I need to know. But obviously as my process goes on, I need to then start looking at what that chair is, the description of it, the manufacturer, the model name, the part numbers. I might need to know how many chairs there are in particular rooms. I might need to count. I might need to, understand all of those details. And that'll be the same with anything really: windows, doors, cupboards. And any sort of model of content that I'm putting in there, and all of those bits of data that's going to be attached into that obviously goes through in these sort of levels of detail. The LOD, or these sort of grades 0, 1, 2, 3, is the kind of AEC type way that we tend to do it. There is another method that's being used, which manufacturers are kind of adopting a lot more now, which is the AIA, or the American Institute of Architects. Their kind of method of doing this is probably a bit more useful to manufacturers, really. So they have a LOD, but it's referring to level of development. And this really sort of starts drilling down into a lot more of the finite details that as a manufacturer you would need to know. So again, you can see the chairs thing at the bottom there really, but also we're taking it a bit further. But you can go down in this sort of AIA system, you can go down into literally the nuts and bolts of component parts and very, very small details. And the AIA standard documents really break down how these things can be organised and how they can be sort of specified inside of the little sort of Revit families or whatever it is that's going to be produced. So I think from a manufacturer's point of view, the AIA standard is probably the one to start looking at. So from a manufacturing point of view, what are we doing? What are we getting involved in at the moment? What we're finding is that there's several ways that manufacturers are sort of utilising some of the softwares to sort of enable what they're doing. Firstly, really, we have a lot of different manufacturing companies that come to us, and they use a lot of different file types, a lot of different softwares to produce, or historically have used a lot of different softwares to produce all their different data inside of their systems. So obviously just listing a couple there, the Solid Edges, the CATIAs and Pro-E. What we're finding now is that to make it part of this kind of BIM workflow, what we tend to do is utilise Inventor as a kind of go-between, really, because Inventor can pull in all of these different file types. We can just bring in whatever we want from Solid Edge or whatever, take it into Inventor, interrogate it, attach different bits of information if we want to in Inventor, and then start pushing it out in other formats as well. So we are finding that Inventor is being kind of used as this sort of middle point, really, to try and open and utilise all these different programs. Particularly from a Revit point of view, Revit can't understand things like Solid Edge and CATIA, so it's easier to take it through into Inventor first. Also, I mean, a lot of manufacturers have basic 2D stuff that they might have done through AutoCAD, and the nice thing about Inventor as well is that there's what's called 2D to 3D tools. So literally, you can take something that's 2D, and you can say, right, in Inventor, I want to make that 3D, and to agree to a point, it will basically automate the process of taking something from a 2D base to a 3D object. So it's a kind of nice little workflow, and it can just basically take 2D data and make it 3D data. So, and then obviously that's then ready to kind of utilise if as required. So bleeding on from that, the other way that we're finding as well is that people have things like shop drawings. They have 2D information in sort of AutoCAD. We are finding that people want that just taken directly into something like Revit. So this is a company called Optima that we got involved with, and Optima wanted us to help them take all of their 2D based drawing works into AutoCAD, so into Revit from AutoCAD. So we've got on the left hand side there the AutoCAD sort of shop drawings, all the different details inside of AutoCAD, and then in the right-hand side there, obviously there's the stuff that we've started helping them produce inside of Revit. So basically creating families inside of Revit is really the important one. So the other way of creating families inside of Revit from AutoCAD and other things might be using Inventor. As a manufacturers, we find that some of our customers are using Inventor already to produce a lot of their shop stuff, because obviously Inventor does feed into the kind of cutting lists and the CNC machines and things. We are finding that manufacturers are using Inventor more and more anyway, and what we're doing now is helping them take that out from Inventor and push that out into Revit and produce families. So this is the Schneider system that we've been working a lot with Schneider recently, and this is just one of their exchange boards, and the top left there is obviously their exchange board that we started with, that they give us in Inventor, and then down the bottom here is what we're then starting to produce in Revit. So you can see in the little image there, you've got things like all the mechanical data, the electrical data that they wanted attached to it, all of that nested data that's inside of it. So really just simplifying the model. I mean, the Inventor aspect of it, they don't need all of that data coming through into the Revit model, because in an architectural environment or an AEC environment, that would make the BIM model very, very heavy if all of that data that's inside of Inventor was taken through. So as part of the process, we're using sort of simplification methods, simplifying something, taking it out into Revit, and attaching all that kind of detail. This is just a little video which was basically doing that system. So this is the sort of simplification system. This was for another company called Microlights that we worked with. So I'll just try how long the video is, but so in here, obviously taking the stuff that they've got in Inventor, just making sure it's in the right orientations and things, and then using the BIM exchange here. So we've got things like shrink wrap, which obviously allows us to simplify the tools that's there. See also there you can attach things like MEP type components as well. So we've got things like electrical connectors, ductwork, all of that sort of stuff. So what I'm doing here is just making sure that it's going to be in the right orientation once it comes into the Revit environment. Next thing you do is looking at the classification systems. So what I was talking about before, so where you've got uniclass, omniclass, all of those sort of different classifications, making sure that any classifications that's being put in here are correct, and also adding in data. So this is just going through adding some data that they might want to attach, so a manufacturer's name, model, part numbers, that sort of stuff. Running a check on the system as well, just to make sure that when it goes out into Revit, it isn't going to be too heavy, that the little family that's being produced in Revit is going to be then a nice small size. Obviously, as an AEC workflow, wouldn't want to start specifying stuff inside of a building that's going to take a lot of space once it gets pulled inside a BIM model. So that's just exporting it out, and then inside Revit here, got a building, and then just basically placing the component in there. So that's the component having come in, placing it into looking at a ceiling plan here, so placing it in, looking at all the details that's now been pulled through as part of the process. So just attaching it into different areas there. So that's the light with its particular light plane there, and all the different details that's been attached. Just interrogating some of it, different levels of detail that might be applied to it. So that LOD that I was just talking about, basically different things can have different levels of detail, so that as you go from sort of coarse, medium or fine or whatever, that's kind of looking at those levels of detail You might have CAD details attached in there, so that if you did a section or a plan, that it would show certain levels of CAD detail if you turned certain aspects on. So again, just showing different aspects here of how it might work. And eventually, obviously, that would be then able to be rendered out. I'm not sure if this has actually got a render on it, but we're talking about all the different, yeah. So this is then taking it out into a schedule, and obviously saying that obviously then that details are then there for the AEC environment, and then obviously in an architectural building or whatever, you would have all of that stuff there that then can be scheduled out with all of that data attached to it. So obviously from a manufacturer's point of view, as I say, I mean, I think the important thing about what I was just trying to show you with this little video is really that there's this little workflow that can be used, and that workflow is really just trying to ensure that the LOD that we were talking about, the levels of detail, the complexity of something that's being produced, the specifications that's being produced inside of it, all of those sorts of bits are part of that process that you're kind of going through as you do it, and obviously that everything is going to eventually be a fairly simplistic little family with all of the data attached to it. So I just put something about IFC to use the subset of IFC, which is COBie, which is what I'll go on to in a minute. But in here, we're talking about something that's then being linked through from one project to another, or from different consultants to another. And again, trying to sort of simplify the system as it goes. IFC basically is just taking it down to basic computer language, that's all. So it makes it something that's translatable between different software systems. Really just to explain that obviously IFC is something that's being adopted a lot more now, so I won't sort of dwell on those too much. As I say, from a manufacturer's point of view, I think COBie is probably the more important one, really. COBie is, as I say, a subset of IFC. It's taking that basic computer language, but then exporting it out into things like spreadsheets here, that, as you can see on the screen. So really trying to take out some of the data that's attached into these things. So like the little lights that I was just looking at a second ago in the video, the data that's attached into those, rather than taking them out into a spreadsheet in Revit, we could be taking that COBie data out into spreadsheets, into an Excel format. This could then be utilized as part of the kind of handover package. So contractors, subcontractors could all utilize this data, and it could already be in there ready for specifying. So I think COBie is something that's becoming known very much in the manufacturing fields now, and it's starting to be adopted by a lot of companies that we're working with from the manufacturing side of things, and they're starting to try and get a handle on what COBie data they might need to attach, and how COBie can be used for any sort of content that they're producing. And again, really just talking about the adoptions of COBie and it obviously, you know, being utilised more and more now. So obviously there's lots of ways that content can then be produced, and once it's been produced, obviously what's happening to it next is really the other thing as well. A lot of people are producing content and they're making it freely available on their sort of web pages, websites, their company's own website sites. Also, it's useful to have your data publicised on a system that's going to be available to everybody from an ease of use point of view. Inside Revit, there's Autodesk Seek. So if I was an architect and I wanted to specify a component, I would be using the Autodesk Seek system that's in there. As soon as I want to go and load in a family, you can go to Autodesk Seek. I could just type in there in a kind of Google search bar type way what it is that I'm looking for. It would take me out into Autodesk's own sort of Seek area of their web pages, and it would bring up content that people have publicised on the Autodesk Seek system. The nice thing about doing this is that I know that stuff that's being publicised on there is going to be produced in the right way. It's going to be the right kind of content. It's been sort of, you know, checked and verified, and it's all right. It's all good. Whereas obviously if I just went to Google and just typed in something, I might not necessarily know what I'm going to be downloading. So it's quite a good process. It also means that from a manufacturer's point of view, you could publicise wares and works on the Autodesk Seek system, and it would be there freely available for people to utilise and specify inside of their buildings. It would be a very quick way for them to find the manufacturer's details that you're publicising, rather than them having to type into Google and then find a web page, and then from that web page download something and go through that kind of process. If they went through the sort of latter process, they might never find you, they might never find the manufacturer's details that you're publicising. So because this system is already built into the software, I think it's a really useful system to utilise to make sure that you are being recognised and that the stuff is out there for people to use. But obviously, like you see there, obviously you can put things like your branding onto it. You can then start tracking obviously the performance of the downloads and things. But say really the important one is obviously making sure that your products are kind of BIM ready, as it were, as a manufacturer. And then once they get to that point, then they can be publicised and utilised in lots of different ways. Navisworks, I just wanted to touch on Navisworks really because it's one of those programs that, particularly from an AEC side of things, manufacturers' details are being put into models, and those models are being used by consultants obviously to analyse and look at and interrogate. Things like Navisworks is being utilised a lot more now on site and a lot more in the construction process, and therefore I think from a manufacturer's point of view, it's one of those things that the data that's attached inside of little families and stuff, once they get into Navisworks, there's other programs as well, which I'll touch on in a second, that are being used to then communicate those bits of data. And obviously, particularly from a kind of quantification side of things, manufacturers' details can then be quantified a lot easier inside of Navisworks, and contractors are using Navisworks now for quantification a lot more than they are things like Revit, because it does it to a higher degree. I think also from a kind of costing point of view, all of that sort of stuff, if inside of the manufacturer's details it said a cost per unit of whatever the item was, again the quantification process would be a bit simpler as well. Data management, obviously managing data, so inside of the manufacturer's details, obviously managing data, manufacturers always often use Vault historically through us, and we've always helped them organise their data in-house, as it were, but from an AEC environment now, people are starting to look at Vault as a way to start organising data for building projects as well. So I think also there's that kind of crossover there between the manufacturing side and the kind of AEC side. So I think obviously from a manufacturer point of view, just understanding again that sort of process. Field and glue and sort of mobile technology is really the big thing at the moment, and that's the big area that things like Navisworks sort of kind of led into really, but now there's the sort of 360, which is online, and again really being able to sort of on site interrogate things live is really, really important. Being able to interrogate an object that's been placed or specified, be able to find out all of the details about it. That might lead into project lifecycle, which again, in a project's lifecycle, being able to pick on an object that once it's been built and have that information that's been put inside of that manufactured component and find out all the different details about it is really, really powerful. And that's really where people are starting to try and lead now. But obviously all of that is very, very dependent on the stuff that's being put into the building in the first place, having that data in there. And that then sort of comes down to you guys really to, as manufacturers, to have that stuff in there as publicised content, as content people can put into building information models that can then be built, handed over, and then taken into life cycle. So I think the sort of mobile technology, which is where things are going, is sort of a key part of manufacturers' data being contained in these things. And obviously then sort of, leading into stuff that's happening at the moment with sort of Google Glass and all of those sorts of things. Again, being able to just sort of walk around the building once it's built and interrogate something and find out all the manufacturer's details about it for when does something need replacing, when does something need changing, where do I go for this, where do I go for that, the websites, the addresses, the part numbers, the part codes, all of those sorts of things could be identifiable straight away just through a simple system like sort of Google Glass or a mobile technology system. So I think it's where things are going, and it's a very kind of powerful system, but obviously all that data needs to be in the first instance. Okay, well obviously thank you for listening.